Answer these questions yourself before you proceed. We're told that the ammeter gives the same reading whether the two switches are open or closed. So the first thing to do is to draw a circuit diagram for the two situations. Here we have the circuit with the switches both open. Here we have both the switches closed. In each situation, there are some parts of the circuit which can be removed because no current will flow through that part of the circuit. So it's as if that part of the circuit was missing. Which parts are these? Notice that in the first circuit, current will flow through the 2, 1, and 6 ohm resistors, but not through resistor R. In circuit 2, notice that the 1 ohm resistor is short-circuited by the closed switch in parallel across it. In other words, at this branch, no current will flow through the 1 ohm resistor's branch because all would rather flow through the 0 ohm closed switch. So we can simplify these circuits like this. Now we can calculate the current strength in the first circuit. The supply voltage is 4,5 volts and the total circuit resistance is 2 plus 1 plus 6 ohms, which equals 9 ohms. So the current strength is 0,5 amperes. The question tells us that the ammeters in both circuits read the same value, so we know that in this branch of the parallel section of the second circuit, the current strength is also 0,5 amperes. We can use this information to calculate the potential difference across the 6 ohm resistor, and we find it's 3 volts. We know that the potential difference across each branch in a parallel section is the same. So from this, we know that the potential difference across R is 3 volts. We know that for each complete pathway, the voltage given by the battery needs to be lost by the resistors in that pathway. So from that, we deduce that the potential difference across the 2 ohm resistor is 1,5 volt. So notice that the battery gives 4,5 volt, and along this path, 1,5 plus 3 equals 4,5 volt is lost to the surroundings. And along this path, 1,5 plus 3 equals 4,5 volts is also lost. From this, we can calculate the current strength through the 2 ohm resistor. In other words, we can calculate I main, and we find that it is 0,75 amperes. So now we know that I main is 0,75 amperes and that it is the parallel section that splits, with 0,5 of it, 0,5 amps of it going to the branch with a 6 ohm resistor. So how much must flow through resistor R? It must be the rest. In other words, 0,25 amperes. So now we can find R's value, since we know the potential difference across and the current strength through R. This is a summary of what we've calculated. Let's check our answer, and we check by converting the closed switch circuit into its equivalent series circuit. So we need to find the equivalent resistance of 6 ohms and R, which we've determined to be 12 ohms. We divide the product of the two resistors in parallel by their sum, and we find that the equivalent resistance is 4 ohms. So we can replace the parallel section by a single resistor of 4 ohms. We know that the potential difference across each parallel branch is the same, and this is also the potential difference across the equivalent resistance. We can use this equivalent circuit to check our answer by calculating the current strength through the circuit, and it should match what we had previously calculated for I main. The supply voltage is 4,5 volt, and the total circuit resistance is 2 plus 4 equals 6 ohm. That gives us a current strength of 0,75 amperes, which is what we found before. So this gives us confidence in the answer we calculated, that R's value is 12 ohms.